Since you just learned the quotient rule and you realize it's kind of a long rule, we want to talk about when should you not use it? When is using the quotient rule actually more complicated than doing something else? So I just wanted to go through just a couple examples. This is going to be a very short video of when using a quotient rule really doesn't make the most sense. So one reason or one time when you wouldn't want to use a quotient rule is when you have a denominator that looks something like this, where you have what I call a single term denominator. When you have a single term denominator, the best thing to do with this, I often call this pretzeling the function. You probably never heard that. It's not really a math term, it just makes sense to me. Split it up into three separate expressions by taking each of them and dividing by x. You are allowed to do this. You cannot do this with the numerator. You can't reverse pretzel. It doesn't work that way. So when you do that, you're going to get x cubed divided by x is x squared. 3x squared divided by x is 3x. And minus 5 divided by x is just going to be minus 5x to the negative 1. We're going to rewrite it with negative exponent. So if you have a single variable denominator, you can very quickly just write each of them over that and do a quick simplifying. You can do it in your head. Then you can derive term by term. So the derivative of x squared is 2x. The derivative of 3x is 3. And the derivative of negative 5x to the negative 1, power out front, power 1 less, and you can rewrite that with a negative exponent in the bottom. So write it as 5 over x squared, rewrite that negative exponent for your answer. So that's one time that I don't think the quotient rule is worth it. You can use it, but it seems like a whole lot more work. If you have a single denominator that's a constant, so let's say you have a numerator that's 3x to the fourth plus 5x minus 2, and you have it all over 8. Rather than doing a quotient rule with that, you want to rewrite it as just 1/8 times the variable expression that's in the numerator. Again, no reason to do a quotient rule when you are dividing by something that is a constant, because now when I take the derivative, I can just leave my constant out front, my coefficient out front, and then derive what's in the parentheses. So the derivative of 3x to the fourth is 12x cubed, the derivative of 5x is 5, and the derivative of negative 2 is 0. So you can leave your answer like that. If you want, you can distribute the 1/8 back through, or you can put the whole thing over 8. But having a constant in the bottom, you can very quickly write it as an expression that doesn't have a denominator that needs a quotient rule. And the last situation where it would not make sense to do a quotient rule is if you had something like this, where your denominator is something that can be written with a negative exponent. So writing 5 over 3x to the fifth, yes, you could do a quotient rule, although it's a lot of work for really the same answer that you would get if you simply wrote it as 5/3 x to the negative fifth. So rewriting, if you can rewrite with a negative exponent, then your derivative power out front, you're going to get negative 25/3 x to the power 1 less. And then you're going to rewrite it without the negative exponent, putting that x to the 6th in the bottom. So those are 3 examples when the quotient rule could work, but it's truly way more work to use it, and you're better off using your algebra skills and your rewriting skills to avoid using a complicated rule.